All right, Andres, Andres Rodriguez, um, one of my old students. So the rest of you guys are my current students, but he was one of my old students here, and he uh, he was. I don't know what you took my digital electronics class, right? I think you
I,
did.
I took I did both your classes.
Okay, yeah, he was when I first started switching to engineering. I was physics forever, and then I started adding some engineering classes. Now I'm just engineering only. But back then I had just started switching, so he was like literally my first engineering student. Literally, that's why I was questioning whether he even was there when I had the second class. So sounds like he was, and I think it was like a zero period class. I think right, had to be.
Yeah,
Yeah,
zero
because they would.
period.
Yeah, they wouldn't give me a regular class, so like a real class during the school day. So we did a zero period. That was before school started. And anyway, he's an electrical engineer, and I want him to talk a little bit about, I guess what he's going to come here to talk about, which is about your job. Yes.
Yeah, I'll explain kind of where I work and then what I do
Okay.
at my
Yeah.
job.
Go ahead and go ahead and get started then.
You disable screen sharing, or you have to. I think I'm good now. All right. I hope you guys can all see this. So Swanson basically wanted me to talk to you about what I kind of do as a power engineer. When you do engineering, you have a lot of different fields, whether you want to be a mechanical engineer, a civil engineer, electrical engineer, chemical engineer. Um, and with all those majors, you have like subcategories in every single one of them. For electrical engineering, I decided to do power engineering, which is just like a focus in what you do. Some people can focus more on computer engineering. Some electrical engineers actually just move on and do computer science. Some do power electronics, and then some do more like computer kind of electrical engineering. What I do as a power engineer is basically do like the electrical designs and project management for your local utilities. Currently, if you, 1 second. Yep. So my education, I went to Cal Poly Pomona. I got my electrical engineering degree there, and I'm currently working for Burns and McDonald's, which is just basically it's a consulting firm. I would say it's one of the biggest consulting firms there is that does engineering, not just for power engineering, but pretty much any type of engineering that does, whether they do big oil projects, solar power plants, construction buildings, and pretty much it's just a big engineering firm. Within there, I'm in their transmission and distribution group, which they do basically where they basically just take projects from utilities all over the United States. I worked in California for 2 years, worked in Ohio for a year. I'm currently in Pennsylvania working here on a project. Basically, to lay it down with a power engineer is you work on the electrical system. So for you people in California, that would either be PG&E, San Diego Gas and Electric, or Edison. And I have worked with some of those in the past. But to kind of summarize what the power system is, it starts off with basically a power plant or a generation, which can either be a solar plant, hydro plant, coal, or nuclear. So basically to summarize short, what the system does, it just changes the voltage of the system up and down to make it safe to use. So the next step after a generation is, these transformers have like kind of gated areas called substations. And the main
Sorry
purpose
to
of this is
interrupt.
just,
What's the main voltage about coming out of that power station originally? I'm just curious about.
Yeah, so the main voltage to start off, so you have all your generations. They'll be coming out of that generation plant about 12,000 volts. The issue
Okay.
with 12,000 volts is that it's not good to transmit that voltage long distance, because you're either gonna lose all that power and heat, or you're gonna need some incredibly thick cables to handle that load. I'm not too sure if you guys ever touched a hot cable, a cable that basically means that your cable was underrated, or you're losing all the power to heat. So you're basically just, it's becoming a heater. The way they solve this is they step up the voltage to about 500,000 volts or 200,000 volts, either or, depending on how long the distance is. This distance can be hundreds and hundreds of miles. So you're talking about moving this from one end of California to the other end of California, which minor losses in energy counts as millions and millions of dollars. The next step after that, you have these transmission lines, which hold the power after it's been upgraded to a specific voltage. And then they'll take it to your local neighborhood, where you'll have another substation. And this substation is basically another transformer, which drops the 500,000 volts back to 12,000, because you can't have 500,000 volts running around your city safely, because it's pretty much unusable. After it gets back to 12,000 volts, it'll go through that's safe enough to run around your local neighborhood. So you'll see, that's where you see your power poles and the big wooden structures. Fun fact about those wooden structures is, you live in a nice neighborhood when you don't see them, because they're underground. It's an incredibly expensive way to do it. On those wooden structures, so it's going to be running around 12,000 volts. If you ever see a big wooden pole, like you see on that last step right before the house that has a big tub, that's another transformer that basically drops the voltage of 12,000 volts back to 120 volts. So that's probably what you guys are all familiar about. And that's basically any voltage you can use with your home electronics. Basically, it's just the power system just changing the voltage up and down. That's basically what a power engineer does. But with each part of these steps, involves designs, and equipment is pretty massive. So I have a few pictures on the next slide where I can show you. So this is basically a substation. I'm sure you guys have seen them around all your neighborhoods. They're just like these big metal looking transformer looking things. They're pretty much in every city, and they name them after the city you're in. So say I grew up in Almani, this could probably be called the Almani substation, and it pretty much powers your entire neighborhood. Pretty much as a electrical engineer and power, it's a pretty unique area, because not only do you do electrical engineering where you focus on just the electricity portion and the electronics portion, you also focus on the physical portion. So you're basically also a mechanical engineer and a civil engineer, because you have to design pretty much the whole substation. So as my job, I design the layout of the station, all the mechanical portions. You also do all the civil portions, which is foundation work, groundwork, leveling. It's pretty much all aspects of engineering. And as a power engineer, you pretty much cover it. So I've designed quite a few of these large stations. So this is more of an older station. And the reason why there's so much work in power, it's considered a niche kind of engineering. It's because a lot of these old transformers are about 25 years old, and their lifespan is only 30. So over the next few years, you'll see an increasing amount of jobs in power engineering, especially because a lot of the old engineers in this field are called dinosaurs, because they've been doing the job for years, and a lot of them are retiring. So there's a huge demand in this niche. Personally, I didn't know about this niche until I went to college, and then that's when I focused on it. So to kind of summarize it, in a substation, this is basically the area where you'll transform the voltage from 12,000 to 500,000, or you'll transform the voltage from 500,000 back to 12,000. And as an engineer, you'll design these. So that's just kind of the physical portion. And then you have the protections and controls. When you're moving this much voltage around, you have to have some kind of controls to monitor the system and see what's going on. It also records the data, lets you know how much power it's being used. And you can think of these devices that, as smart multimeters. I'm not too sure if Swanton has introduced you to those, with an Arduino attached, that are incredibly just expensive. But basically all they do is monitor voltage, monitor current, monitor the frequency of the power, which kind of, they do a lot of other factors, but they're pretty much monitoring the system. So say a bird hits one of the transmission lines, or someone decides to throw their shoe on the transmission lines, they'll detect it and pretty much stop it from just blowing up. The reason why you can throw a shoe on your transmission line without having the whole thing just burst into flames is because these devices sense that something's there and they'll shut off power immediately. So it's pretty much a big safety feature. Also, another thing they can detect, say there's big winds in the area and a pole falls down to the ground, it'll detect that that pole has fallen on the ground, and you can't really have that much power just lying down. You'll instantly kill someone. So these devices detect that and they'll shut off the power for that specific section. So that's basically what these do. They're basically just expensive multimeters and switches. Back in the day, they used to have people at each station controlling the entire station of what's turns on and off. But now everything's smart and everything can be done through fiber networks and just a big network system. So now just a group of people in a small control house controlling pretty much all of your California power. So that's so in a design engineer, you do both the physical and then you also do the PNC. These have thousands and thousands and thousands of wire connections. This also comes with programming as well. These devices need to be programmed. You also need to set up protection schemes and design. So that's that. Let me see. Currently, I did design for about 2.5 years. Now I moved out here to Ohio and Pennsylvania to be a project manager, which I use my knowledge of design to kind of. So basically, before I used to be the design engineer who designed how the substation is laid out, how the controls are set up and wired and programmed. Now I'm a construction manager, which figures out how to make those drawings into reality. So it's easy to design something. It's a lot more difficult to figure out how exactly you're going to move a piece of equipment. So say this is a transformer. So this is your device. Something this large would be a 500,000 volt transformer. This is a transformer that would either step down or step up your voltage. And this is just a picture demonstrating how just moving one piece of equipment is pretty difficult. So this transformer, is on a railing system. It's like called a jack and slide. And they're basically just using kind of compression to slowly move this transformer from one end of the station to another to put it in the correct position, just inch by inch. But yeah, so it's kind of, I put this picture up to show kind of some of the situations we run to as a project manager, where you have to turn the design into reality. And nowadays I'm managing construction crews, bidding out big projects, doing a lot of financials and pretty much managing schedule and figuring out some of the design issues that I get as a day-to-day basis. So it's a kind of a next step after you do design, which as an engineer, you have these routes across any engineering field. So usually to an engineer, you'll start off as doing design. And if you want to move to management or project management, that's your next step. If you guys have any questions, you can feel free to ask.
Yeah, if you guys want, yeah, you guys can ask any questions or shoot them in the chat if you guys have any. Is it actually like a promotion or a raise to go from designing like you did to like project management, or is it just another job and it's like about the same?
It's usually not that significant. Most of your rate, it's just a different path. So say you do design and you just get tired of doing design, grinding it out. It's just a different path of where you want to be more of on the field.
Which one has longer hours? How about that?
Usually I had longer hours as a design engineer, because you'll get packages and packages of designs back to back, and they just never end. With the project manager, it's more up to you to figure out how the schedule is going to go. But there is days when you're in construction and no one, and as a project manager, no one's going to care about the project more than you do. So if you need to work weekends or work until the project is done, that's pretty much up onto you. If something blows up, it's on you. If something goes wrong, it's on you. If someone gets hurt, it's on you. So you're taking full on responsibility for the project, both financially, and also you're taking responsibility for safety of the people and making sure that project gets done on time and on budget.
Okay.
So it has a different kind of challenges. As a design engineer, it's a little bit longer hours, but it's more kind of relaxed because you get a scope of project, you design it based on your knowledge that you learned in college. And a lot of the kind of the knowledge you learn is also learned at the job. And it's up kind of, it's has its difficulties because it's new. A lot of designs you do is new, but you have your support for that. So I personally like project manager more because I like to be in the field and see how things get built. And that's kind of the reason why I chose project manager.
Okay.
But it
And
is more like a senior level position.
the one you did before, the designing, and they would just keep send you packets and packets of design. Did they pay you for each one you did, or was it like, oh, I only got paid a certain amount, so
So there's different fields. So if you can do the same amount, you can do the same works. Like say you decide to work for the utility, you can work at Edison, or Edison or PG&E or SDG&E, and you'll pretty much do the same work, but you're gonna be on a salary. If you guys decide, but they also give you less work than a consulting firm. So currently I'm in a consulting firm, and it's kind of, I'm not too sure you guys are more familiar how lawyers get paid. They get paid by the hour. In a consulting firm like I'm in, we get paid by the client for every hour that we work. It's kind of more of a premium that they pay for that, but we have a lot more resources than a client would be able to support having full time forever. So they use consulting firms as an extra resource for design and for big projects that they can't really do in-house. So as a consulting firm, you would get paid by the hour with a confirmed salary. So say you want to make, they offer you $80,000 a year, you'll get paid $80,000 a year no matter what. But additional hours that you do work, say you work 80 hours in 1 week, you'll get paid for each one of those additional hours. So that's the benefit of working at a consulting firm, but you're also kind of more forced to work extra hours. So if you work for the client side, say Edison, most of those guys will only work 40 hours because they're giving less workload. Most of the time, if they have more work, they'll pass it on to us. And us being more of a business model, we're kind of pressured to take on more work and do more design.
Gotcha.
But you get paid for it. So it's whether you want to make more money or have a more life balance. The choices to you.
Okay. Well, I think that's it then. I didn't see any questions in chat, so maybe we'll get some next time. But thanks for your time, and everybody, for you guys, your assignments on Google Classroom. You guys can just go there, and you guys have a good 3-day weekend for all you guys in my class. And thanks, Andres, for coming in, man. I really appreciate it. All right.
Thank you.
Yeah.